What are you going to tell us about today?
I'm doing pretty good, but I've got some bad news.
Uh-oh.
Oh, no.
One of NASA's spacecraft crashed into an asteroid. Completely ruined. That's true. Well, it's not that bad because they were trying to crash into the asteroid. Some of you might remember, I'm talking about the DART mission. And this happened several years back in 2022.
Oh,
and thank goodness it wasn't one of those expensive satellites, you know, like our James Webb Telescope. But it's exciting because just recently they determined how much they were able to move that asteroid. And I want to talk about that, but I think we better start by jumping back and looking at the DART mission and remember what happened. So the idea was they fly the DART spacecraft all the way out to the asteroid, and then they fly it right into Dimorphos, which was the little moonlet that was going around the bigger asteroid. The bigger asteroid was Didymos, which was only about 1,000 feet across, and Dimorphos is only about 500 feet across, so relatively small, but they were able to do it precision perfect and crash into it. And it sounds, you know, simple. It's NASA, they do these kinds of things, right? But if you think about what that means, there's this asteroid binary pair going around the sun, and they have to fly all the way out there, and then they're aiming for the moonlet that's going around it, and they have to have it timed perfectly, so right at the right moment they come through and they hit it. And they were able to pull that off. And the idea of the mission was to see if something like this could be used to steer asteroids, to move them to a different orbit in case there was an asteroid that was actually going to hit Earth. You know, like in the movies, we always got to be ready. So I want to show you a video from the DART mission as it's approaching the asteroids. You can see down there Didymos and then Dimorphos, the little one they're aiming for, and it's coming around, and they're getting closer and closer, and this is sped up frame by frame. But you can see as you get closer, it's kind of almost like a big rock pile floating together. And then we slow down frame by frame as we're getting closer, and then whack. And the last image didn't come through all the way because it didn't have enough time to send. But it hit the asteroid perfectly. It was a wonderful success, and the plume came off. They had another little cube satellite from the European Space Agency that was following behind to take pictures. And that last frame that was the full frame was, it looks like, you know, just gravel, but that's about 100 feet across. So those little rocks are actually big rocks. And after it hit, they pointed the Hubble telescope right at the asteroid and looked at what happened. And here are 3 different frames. You can see 22 minutes after is a little bit of a cloud, and then 5 hours, and then 8 hours, the cloud got bigger and bigger. And they were able to tell they really hit it, and a lot of stuff came off. Well, they've been studying the orbit, and they found that they changed the orbit rate of the moonlet around Didymos by about 30 minutes. And then they changed the actual orbit of both of them together by 1.5 seconds. So that's only a teeny bit, isn't it? Especially when you realize that the orbit of this binary asteroid cluster is about 2 years. Mm-hmm. So out of the 2-year orbit, they changed it by 1.5 seconds. It's like, oh, then it's not very big change. But when you think about it, it wasn't going to hit Earth, and they didn't want to change it too much and make it hit Earth or something. So it was a good test. They carefully chose an asteroid that wasn't going to get changed to hit Earth for sure, because that would be another kind of movie, you know, that we don't want. But even though it didn't make a big difference, it actually proved a lot of concepts. First of all, they hit the moonlet and changed its orbit around the bigger asteroid, and that changed the orbit of both of them. Because really, together, they're orbiting the sun, and their center of gravity between them is what changed. And so it changed the orbit around the sun. But then also, we understand the physics, or we proved that we understand the physics, right, of this situation. So if we were going to try to change an asteroid, we could actually figure out now how fast would we have to be going, and how heavy would our spacecraft need to be. And the other really interesting thing was when the DART probe hit the asteroid, a whole bunch of stuff came off, and they calculated that that doubled the impact, or the change that the impact made when it hit. And so that's really interesting, because the material makes a big difference too. And why does this matter? You know, we don't know of an asteroid that's going to hit Earth, but we're trying to find out more and more. There is an asteroid, though, coming in 2029 called Apophis. And this is one they discovered back in 2004. And when they discovered it, there was a chance it was going to hit Earth. And it's big. It's, you know, like over 1,000 feet. So it would be a really big deal. And they've been tracking it really carefully. And now they're sure it's not going to hit Earth in 2029. And there are a whole bunch of scientific missions going to explore it and study it as it goes by. And I want to show you its path as it comes by Earth. If you look at this map, those dots are our satellites, mostly like our geosynchronous satellites. And it's going to pass so close that it will be closer to Earth than our GPS satellites, way closer than the moon. So that gives you an idea of how close this asteroid is going to be. And again, it's huge. So it's going to be really visible in the sky, you know, like bright like Venus, for the people who luck out and are in the night side and have the right angle and everything, they can see that. So instead of it being a disaster, it's going to be something really exciting. But every once in a while, they find a new asteroid, and there's a period where they're trying to figure out, now, is this going to hit Earth? Is it going to hit the moon? And the idea is if we can find it soon enough, then we'll have time to be ready. So NASA's getting ready to launch another Surveyor, the NEO Surveyor spacecraft, in 2027, next year. And it's going to be looking for these asteroids. We should be able to discover almost all of them that might hit Earth, at least you know, the bigger ones. And so that'll be really, really useful. And so, you know, we can start planning, and as long as we have enough time. But speaking of time, that's all the tech we have the time for.
Oh, wait a minute, though. Wait, I got a question. Okay. I got a question. Incoming question.
Yeah.
So if the debris that was knocked off by the collision had an impact, what if they put a nuclear warhead on the rocket that hit it? Wouldn't it have a greater impact?
I think it would. Definitely, yeah.
So if we could, instead of going into it while it's rotating, what if we went behind and we shot our moon, and maybe we get more sleep every day?
That would change a lot of things about the tide and stuff.
Or we could have R51 just put a steering wheel on the asteroid. All right, well, thank you very much.
All right,
Share
thank
for
you.
him.